So today we talk about derivative y equal to e to the u and then y equal to ln u. So first of all, I want to talk about this exponential function derivative from first. Okay, so according to textbook, you see that if we have y equal to e to the x here, then dy over dx also equal to e to the x. Okay, then how do you know this is correct? So we just search out graphical approach and y derivative e to the x is just itself using the GeoGebra program. Okay, so let's go to GeoGebra program. So here, I'm gonna make a GeoGebra line here. So I'm gonna move a little bit left so you will see my setup as well. Okay. Now, as you see, this is the exponential function y equal to e to the x. I'm gonna make a point on here. So just making a slight feature so you can see that the point is moving on this object. Okay. Now, what I want to do, I'm going to set up tangent line. So, as you see, I build a tangent line here, right? Okay. Now, I want to ask you, so, what is the meaning of the derivative? Yeah, derivative means we are finding tangent line slope, right? So, most likely, we're going to set up tangent line slope. That's the reason we do derivative here. Okay, so when you look at point A, so you see that 0.44, that's a corresponding order pair, but they also represent basically tangent line here. Look at here. So now what I want to do, click this and then make object trace. So which means whenever we're finding out tangent line slope, what is going on. Okay, so if I'm moving this one on the left side and the right side, so as you see, tangent line moving up and down here, right? And then what happened? Basically, tangent line just on y equal to e to the x graph exactly, right? Do you see this one? Yeah, that's the reason we can say derivative e to the x just itself. Okay, so using the GeoGebra we confirm that basically derivative y equal to e to the x is just equal to itself basically, right? Then using this basic fundamental concept we can also develop such as fx equal to e to the u. You can be any other functional expression as well. Then you can using the chain rule and this become f prime x becomes e to the u, but chain rule you need to do u prime as well. Okay, so let's look at one simple example. So I'm gonna give you example, maybe fx equal to e to the 2x squared minus 1 like that. Okay, then f prime x so far itself, which is the 2 to the 2x squared minus 1. Now multiply derivative of, so derivative of 2x squared minus 1, which is 4x, right? So multiply 4x here. Therefore, in this case, f prime x becomes 4x times e to the 2x squared minus 1. That will be the answer for this problem. Okay, then let's look at natural logarithm function derivative as well. So I also set up gx equal to ln x. Now let's find out derivative of gx. Okay, so instead of writing everything, actually I copy from the textbook and then we just double check together basically. So look at this problem please. So now we just set up y equal to ln x. Then you know that whenever we have this like a logarithm function case, then one side you see log, then the other side the inverse become exponent, right? So logarithm function we always solve for exponent basically. So now from here to here you switch, this is the exponential form, then you can write e to the y equal to x. Okay, now then just do derivative, implicit differentiation method, then you have d over dx e to the y equal to d over dx x, and you know this become 1. Now we just confirm that e to the y become itself, but this time we have to make dy over dx because we are doing derivative y based on dx. That's the reason we have to input this one here, and then you divide by e to the y, then this become 1 over e to the y here. Okay, now then we wonder how can we go from here to here, right? Then please go back to the original format, and now we make this equal to this, so you know e to the y equal to x. Therefore we can replace e to the y as a x here. So based on this proving, we can confirm whenever we have ln natural logarithm function, then you can find out g prime x become 1 over x. Okay, so this is the basic natural logarithm formula here. Then what about this is not x anymore, so it can be another functional expression. So I can make maybe h x equal to ln maybe 3x squared plus 4 like that. Okay, then you temporarily treat them as a u, so this becomes u, and then you can use the chain rule basically. Okay, so h prime x, we know that 1 over this one, which is 3x squared plus 4, multiply derivative of this one, which is 6x. Therefore h prime x becomes 6x over 3x squared plus 4. So basically that's the property for derivative like exponent function and the logarithm function. Okay, so from next video we may combine all different functions together, and then we solve some practice problem. Okay.